Morning students, in the previous video session you have gone through the motion of connected bodies, and today we can see a very important 3-mark question and a 5-mark question. On that, first thing is about the Lami's theorem. Before going through this Lami's theorem, you can go through concurrent forces. So concurrent forces, or you can tell coplanar or coplanar forces. Assume that this is a plane, one surface, and on this surface this is a center. So on this surface some different forces acting from different direction, and all these forces which is joining at a point. So this is F1, this is F2, and this is F3. So arrow mark you can keep it inside. So three forces here, you can see three different three forces from different direction which is acting at a common point. So that this collection of forces, we can tell it is a concurrent. So you can tell that this is concurrent, and it is not it is an important thing. These concurrent forces need not to be in same plane. If they are in same plane, we can tell that they are concurrent forces, or you can tell that coplanar forces. Assume that this is on surface, here different forces acting, and all these forces which is acting at a point, common point, so that you can tell this is a concurrent. And assume that all these forces are acting in one plane. If all the forces acting in one plane, you can tell that is coplanar forces or concurrent forces. So let us see what is this Lami's theorem, and this is what a coplanar force, or you can tell that concurrent forces. Now discuss the Lami's theorem. Assume that this is a coplanar surface which is kept at equilibrium. So that here three forces which is acting at this common point. This is force 1, and this is force 2, this is force 3. So three forces which is acting on a plane. So this is a coplanar plane. Now what is this Lami's theorem means? You can tell that this angle is alpha, angle between F3 and F2 is alpha, angle between F1 and F3 you can tell gamma, and this is beta. Just considering three angle alpha, beta and gamma. Now what is this Lami's theorem means? The magnitude of each force, here you can see that F1 is a force, F2 is a force. So this magnitude of each force, for example magnitude of F1, magnitude of each force of the system is proportional to the sine of the angle between other two forces. Actually this F1, if you are taking this F1 force, the magnitude of F1 we are taking means this magnitude of this force, we can tell that it is proportional to the angle between, this is what the sine of the angle between other two forces. If you are taking this F1, opposite angle is what? Alpha. If you are taking this, so that it is proportional to sine alpha. If you are taking F2, for that opposite angle is what? Beta. So the magnitude of F2 is proportional to the sine of the angle between other two forces. That is what Lami's theorem. If you are taking F3, so the magnitude of F3 is proportional to sine of the angle between what are other two force. So if you are taking F3, this is F3, so this angle, so sine gamma. So the same equation you can write up. Therefore, you can write this equation F1 divided by sine alpha equal to F2 magnitude of F2 divided by sine beta equal to magnitude of F3 divided by sine gamma. So this is a very important 3-mark question. So what is Lami's theorem means? You can tell that the magnitude of each force of the system is proportional to the sine of the angle between other two forces. I told the example and the explanation. If you are taking the force 1, so the magnitude of the force 1, how you can tell? It is proportional to what? The angle between other two forces. Sine of the angle between other two forces. So for this F1, F2 and F3 are other two forces. For this angle is proportional to what? This force. That is what Lami's theorem. And you can write this magnitude of F1 is proportional to sine alpha. Like that, if you are taking F2, magnitude of F2 is proportional to sine beta. If you are taking F3, it is proportional to sine gamma. So this is what the Lami's theorem. And what is the use of this means? We are using this to analyze the forces acting on the object which are in a equilibrium. For example, you can tell that this is in equilibrium. Now this is what a coplanar plane, or you can tell concurrent plane. And in this what some forces are acting, and this is now equilibrium. Equilibrium means what? All the forces acting in at a point and it is not moving, it is at equilibrium, static equilibrium. So we can analyze the forces acting on this object by using this Lami's theorem. That is what you can see in page number 129, 3.4 Lami's theorem. It is very important 3-mark question. So this diagram also you have to draw. You have to write the definition. Definition I said the magnitude of each force of the system is proportional to what? The sine of the angle between other two forces. So this is what the Lami's theorem. Next we can see a very important 5-mark question. So this is one of the very important 5-mark question in this unit. Many times in the final exam they asked this 5-mark question. Law of conservation of total linear momentum. Actually, you know, before also you have learned some of the law of conservation, like law of conservation of energy. We all know that always the energy is conserved. That is what the law of conservation of energy. And here it is saying about momentum also conserved. That is what here it is proving. So we know that in physics, we know there are 3 laws in mechanism. That is what the conservation, 3 conservation laws in physics. You can tell that the conservation of total energy, conservation of total linear momentum, also conservation of total angular momentum. Actually, that is what I said before in smaller grade and all. You have learned about the law of conservation of energy. There you have learned it is the energy is conserved, and here we are going to learn the momentum also conserved, and here we are going through about this linear momentum, conservation of total linear momentum. So mainly I said in physics 3 laws of conservation: conservation of energy, conservation of total linear momentum, and conservation of what? This angular momentum. Actually, this conservation of law of conservation of total linear momentum we can prove by using Newton's second law and third law. We know that F is equal to ma. That is what Newton's second law. and this equation is came from F is equal to dp by dt. So here we are going to prove momentum is conserved. For that we can take this Newton's second law, F is equal to dp by dt, as well as Newton's third law. This is what Newton's second law, and Newton's third law we can take up. So we know that every action there is an equal and opposite reaction. This is what Newton's third law. So there is what minus F12. So this is what a Newton's third law. For every action there is an equal and opposite reaction. I said for this, if you are placing an object, so one particle will exert a force on what another particle, and the same. Suppose here two particle is there nearby. We have seen like mass m1 and m2, m1, m2. So if you are applying force here, what will happen? This mass m1 will exert a force. So this particle will exert particle 1 you can keep. So here you can keep two particle P1, P2. So if you are applying a small external force, what will happen means this will go and hit this particle, so that this particle 1 will exert a force on this particle 2, and the same the particle 2 will exert what a force on opposite, equal and opposite force on this particle 1. Suppose when you are applying 10 Newton force, this 10 Newton force is what this particle 1 will exert the same 10 Newton force to P2, and from P2 also what the same 10 Newton force will act on this particle P1. So this is what we hear happening. So what is happening means when two particles interact with each other. Here you can see two particles P1 and P2 is interact with each other. So they are applying, so they are exerting what equal and opposite forces. So that is what F21 is equal to minus F12. I said this particle 1 is exerting some force on this particle 2, the same thing. So the same equal force is exerting by this particle 2, but in the opposite direction. That is what we are taking. F21 is equal to minus F12. So if you are taking the same in Newton's law, second law, so F21 you can write dP1 by dt, and F12, this is 12, F21 you can write dP2 by dt. Vector also you can put Now you see what is this P1? This is what this P means, we know the momentum. So this is P1 means, here we are taking the P1 means what the momentum of particle 1 which change due to the force F12. So here you can see P1 and P2, and what is this P1? This is what momentum of particle. Actually I said that here some external force is applying 10 Newton. So the same 10 Newton force is exerted from this particle 1 to 2 and this 2 to 1. So every time when there is a change in force, what there will be a momentum also changing. So that is what here we are taking the P1. It is the momentum of the particle 1, and why it is changing due to the force of 1, 2. And the same thing here you can see the momentum of particle 2 is changing because of the force 2, 1. So from here force what is acting? From here force 1, 2 is acting. From here force 2, 1 is acting. So due to this force, what the momentum also changing. So that you can take this is equation 1, and this is equation 2. Now what you have to do means you have to substitute 2 in 1. So F12 means what this value will come, so that when you are substitute, what you will get? So dp1 by d2 is equal to minus dp2 by dt. So if you are taking this minus dp to this side, what will come means, so dp1 by dt, when minus come this side, dp2 by dt equal to 0 you can write. So if here d by dt is common, here also d by dt is common. So d by dt of inside what will come? p1 will come, p2 will come, equal to 0. So this is what we can tell that p1 plus p2 means total linear momentum. Total linear momentum between these two particles. Here I said the two particles are there. So this p1 plus p2 means what? The momentum, which is the total linear momentum which is acting on this particle. So this is what here we proved. You see, d by dt of p1 plus p2 equal to 0, we can write what? So we can tell that this momentum, this total linear momentum is conserved. Equal to 0 means we can tell that the total linear momentum p1 plus p2 is conserved. So here again you see, we are taking Newton's third law and we are using Newton's second law, and Newton's second law we are using by using the momentum equation, and here p1 and p2 means we know here what the momentum of this particle 1 and 2 is changing due to the force F12 and F21. So that here you can take this is as equation 1, this is as equation 2. Now substituting the second equation in 1, so that I am taking this minus part to this side, and you can write what this d by dt is common, so you can take it outside. So p1 plus p2 is equal to 0 you can tell. So this is what by using this Newton's second law and the third law it is proved total linear momentum is conserved in the system. So based on this, there is a law given: if there are no external force acting on the system, then the total linear momentum of the system is always constant vector. In other words, the total linear momentum of the system is conserved in time. Here you can tell that the conserving means this p1 and p2 can vary in such a way that this p1 plus p2 is a constant vector. So assume that if there is no forces acting on the system, so that we can tell that always the total linear momentum will be constant. Otherwise we can tell that the total linear momentum is conserved. So conserving means we know that the p1 and p2 will change any time. That is what conserving. So again you can go through that definition. So assume that if there is no forces acting on a system, assume that one particle is there. So assume that one particle is there. You can tell by the best example, the best example I will tell, the gun. You know that when they shoot the gun, there will be a recoiling moment. Recoiling moment means you know that once the gun is fired, that gun is what acting. It is going forward. The bullet from the gun is going forward and with the same force. So you see, when the bullet is going from the gun, there is a change in force. So what momentum of the particle also changing. So when the bullet is fired by using the gun, the bullet is moving forward. When the bullet is moving forward, there is a change in force. So when there is a change in force, the momentum of the particle is changing because of the force exerted on that. Now when the gun is going forward, backward what will be there? Backward you can see that the gun will push backward. So there is a change in again force. So there is a force exerting on it. So what will happen? There is a momentum of the particle is changing. That is what based on this here on definition given. So if there is no force acting on it, the system, then what if there is no force acting on that gun and bullet, if you are taking that gun, assume that there is no force acting on that. So there is no forcing acting on it means you can tell that the total linear momentum, there won't be any momentum, because if there is a change in force exert on that object, then only there will be a change in momentum. So in that gun, if there is no force exerted, then what will happen? Then you can tell that this total linear momentum is also always constant. So that is what you can tell on best example, and in this part you have to write all these things and the explanation what I told. Also you have to write one example. Here you can see on a person. This is what so this is what I said the example. Here you can see this person is firing by using the gun, and here the system is what the gun plus bullet is the system. So you know that initially there is no forcing acting on it, so it is at rest. So the gun and bullet both are at rest, so that you can tell that the total linear momentum is 0. Now what is happening means so you can tell that P1 is the momentum of the bullet and P2 is the momentum of the gun before firing. So P1 is equal to 0, P2 is equal to 0, because both are rest. So actually this example just firing a gun is given. Before I said the same thing, firing a gun, and here gun plus bullet is the system. In this gun plus bullet system, what is happening? First both are at rest. Gun is at rest, bullet also at rest. When both are at rest, the particle, momentum of particle P1 and P2, both are what? Total linear momentum is 0, you can tell. And P1 total linear momentum is 0 means what? P1 also 0, P2 also 0. But once the gun is fired, so P1 is equal to 0, P2 equal to 0, so that the P1 plus P2 equal to 0, you can tell. Now it is saying that after firing also this will be 0. That is what the law of conservation of linear momentum. So once the gun is fired, what will happen? I said before, there is a force exerted on the bullet so that it will move in forward direction, isn't it? So when the bullet is moving in the forward direction, its momentum is changing. For example, before the momentum is P1. Once the bullet is moving forward, now the momentum is changing to P1 dash. So here the momentum of the particle 1 is changing from P1 to P1 dash. At the same thing, what is happening? Here bullet is going forward. Now you can see that the gun will move back. So what is happening means there is a change, particle 2. So now the gun is moving back means before particle 2 is the gun. Now what is happening? This is also changing. Now P2 is changing to P2 dash. So now due to this conservation of linear momentum, you can tell that if P1 plus P2 is equal to 0 means what will happen? P1 dash plus P2 dash also will be 0. So that you can tell that here P1 dash equal to, if you are taking this P2 this side, it will come minus P2 dash. So you see again momentum is conserved. So this is what you can tell. This is what you can tell recoiling momentum. Recoiling momentum means what? You can see that after firing, what will happen? The bullet will move forward direction, but suddenly you can see that the gun is moving with the same force which is in the opposite direction. So there is a backward momentum also. So that is what we can tell it is a recoil momentum. And my dear students, you can go through this page number 130-31. Here 3.5. This is a part. It is one of the very important 5-mark question. Along with this, you have to write about this example, firing a gun example also. This is what a long answer question number 1. So take this as your homework. This week, this is the first homework for you, law of conservation of total linear momentum. This is your assignment. Write this, study this, write this in your book. Thank you all. See you.